Vectors revision. So as with the last video, this is revision of the main themes, the main ideas, the main skills that you learn in this topic. So I'll go through all of these, I'll go through a couple of examples as well. And as with the last video, once you've got familiar with all of the basic examples here, you should then be thinking about looking through your notes for some more detailed and a wider range of examples, and you should also be thinking about trying lots of these in past paper questions. So let's get started. So how do we write a vector? Well, we've got two options really. One is to simply give it a letter. So let's give this the letter U, and when we do that, if you were to see it in text, it would be bold. That would tell you it's a vector. Or when we're writing it, we tend to just underline it. So we could call that the vector U. Or perhaps more descriptively, another name we could give that vector is, it's the vector going from A to B, we could call it the vector AB. So that's how we write a vector. How do we find a vector? Well, to find a vector from A to B, if you know the coordinates where it starts and finishes, in other words A and B, then we're going to do B take away A. And when we do that, we find the coordinate B, and we actually turn the coordinate into a vector. So 4, minus 3, 5, and we're going to take away 2, 1, minus 7. Just like with straight lines, be careful of double negatives here. 4 take away 2 is 2, minus 3 take away 1 is minus 4, and 5 take away minus 7, well that's 5 plus 7 is 12. So AB is a vector 2, minus 4, 12. Sorry about the so much think there. So what else could we do? Well, we could also write that in terms of I, J, and K. So instead of writing it as a column, we could write it as that's 2 lots of I minus 4 lots of J plus 12 lots of K. Magnitude of a vector. So just like with the straight line topic, it can be seen as the distance between the 2 points or the length of a line that's connecting the 2 points. So let's say we want to find the magnitude of the vector U, which connects A to B. So first of all, we're going to have to find the vector U, or AB, however you want to call it. So AB is B take away A, and I'll fast forward through this. So there we go, we've got the vector AB. Now let's apply the magnitude formula. Now, we can either write it, if we're writing it as U, then we would put the letter U, and we would put 2 lines either side, and that means magnitude. Or we do exactly the same if we're talking about the vector AB. Either way, write down the vector and put 2 kind of straight brackets around it, I guess you could call it there. And we're going to use the magnitude formula. So again, like the distance formula in straight lines, it's very much based on Pythagoras. So we are going to square root. And this one is actually slightly easier, because all we're going to do is we're going to take each part of the vector, square it and add it together. Okay, so if you want to think of it as x, y, and z, you're going to square root x squared plus y squared plus z squared. Or in this case, minus 5 squared plus minus 7 squared plus 0 squared. So that's going to give us 35 plus 49. It's going to give us the square root of 84. A couple of things we can do here. We can pop it in a calculator, we can find an answer. Or alternatively, if the question says write it down the exact value simplified as possible, what it means is write it down as a surd and simplify. So we should be thinking then about square factors again. So we're thinking about 4 is a factor, 9 isn't, 16 isn't. I think our biggest square factor is going to be 4. So we can write root 84. I can write this in red because this is something that you'll have to do depending on the question. So quite often you might just leave it like that. So we could write this as root 4 times root 21. 21 times 4 is 84, and this becomes 2 root 21. But that's only if it asks you for a simplified exact value, okay? A lot of the time that'll be our answer. Collinearity, so again, just like in the straight line topic, we're looking to show that 3 points lie in a straight line. The difference is, this time they are three-dimensional points, so we can't work out m for gradient. Now, we're going to think of a similar idea, which is we want to know whether the heading, I'm not going to use the word parallel here, oh, if that does apply, I'm going to use the word, the phrase, in the same direction. Okay, so the question is, how do we show that two vectors are in the same direction? Well, let's start off by finding those two vectors that we need, and then we'll talk about whether they're in the same direction. So we're going to find the vector A, B. And now we're going to find the vector BC. Okay, so we've got two vectors. Now, if this was a straight line topic, then we're very much thinking, is the gradient equal to the other gradient for them to be parallel? So if it was 3, it would need to be 3 on the other gradient. However, that doesn't quite apply the same way with vectors. These vectors are clearly not equal. It doesn't mean they can't be heading in the same direction. And the way we show that they're heading in the same direction is if one of the vectors is a multiple of the other. So what I tend to like to do is I like to write down AB, change pen here, vector AB is equal to vector BC. Now that's clearly not quite true here, but I like it as a starting point. So what I've then said to myself is, can I make this true by putting some number in front of one of these? Now I suggest you do write it down, because the temptation is to put 2 in front of here because, well, that's twice as big. But if you look at it this way, if I put a 2 in here, what I'm saying is that a vector 2, 3 minus 4 is the same as 2 of these. That's not true. I would need to have 2 of these to make that. Okay, in other words, 2 times AB is equal to BC. And what I then like to do is, by showing that one is a multiple of another, I've shown that they're in the same direction. So I like to make this the start of my sentence. So I'm going to continue from here. Okay, I've shared a common point. My common point is B. Therefore, collinear. 2 things I need to very, very clearly state here. I need to make sure I've shown this, and I need to share common point. And can you tell me what that common point is? There we go. That's how we show that 3 points, 3 three-dimensional points are in a straight line or collinear. Now, there's one thing I want to focus on just to finish this question off, which is sometimes you're asked to write down the ratio that B divides the points in. And it's tempting just to say, well, the ratio is 2 to 1. I advise you make a separate sketch at this point, and you write down A, and you write down C, and what this is saying is that the distance from B to C it takes 2 of these small distances to make up one of these distances. This distance is twice as big as this. So if we were to put B here, the distance from B to C is twice as big as the one from A to B. So the ratio that B divides AC is actually 1 to 2. I'm going to do it a different way in case that's a little bit hard to follow. So you've been asked to show the ratio, you've established what the collinear. What you could do also is you could simply write down, let's say, the x coordinates of each one. So we've got -2, we've got an x coordinate of 0, and we've got an x coordinate of 4. And then what you could do is you could look at the gaps between them. How far is it from A to B? Well, that's a gap of 2. It's -2 to 0. How far is it from 0 to 4? It's a gap of 4. So we get a ratio of 2 to 4, which simplified is a ratio of 1 to 2. Okay, and that just, perhaps is a long-winded way, but it avoids that mistake of simply writing down 2 to 1 and getting it wrong. Dot product. So there's quite a lot of aspects to this, and one of the hardest things about the dot product is that it's very hard to see what the purpose of it is by itself. We use it in quite a few different ways to get some results, but what does it mean by itself? That's quite a complicated topic. So we're going to focus first of all on literally just first of all finding the dot product. In other words, we're going to find u dot v. Now, one way of doing that is if we know the components, whether they're written in this form or this form, is to know the components of both vectors. And if we do that, here's what we do. Well, first of all, I don't really like dealing with this kind of vector to do dot product, so I'm going to write it like this one. So u is 4, 7 minus 2, and v is, now I'm thinking I, j, k. I've got 3 of them. J, I don't have any j's in here, so I've got a 0. And how many k's have I got? I've got minus 4. So to find the dot product, I do 4 times 3 plus 7 times nothing plus minus 2 times minus 4. Now, what I've got to be careful with here is this double negative. So that's 12 plus 0 plus 8. So the dot product here is 20. Okay, another name for the dot product is the scalar product. And one of the reasons I actually like the phrase scalar product is it tells us that the answer is a scalar, in other words, just a number. Okay, so the answer should not be a vector when you do a dot product. Okay, I see some people writing things like this. They end up with the result 12, 0, 8. Okay, that's not what you get for a dot product. Add them together and you get 20. So let's talk a little bit more about why we might actually use it. Well, the most important result is to do with perpendicular lines. So if two vectors are perpendicular, then u dot v is equal to 0. Okay, so if you're asked to show that if two vectors are perpendicular, what you ideally want to do is test for dot product, and you want to get the answer 0, and then you want to write down therefore perpendicular. Okay, or sometimes you are told that two vectors are perpendicular, and what you then can say is, well, that means that the dot product must be 0. So then, for example, let's say you don't know one of the letters. I'm sure you've seen lots of examples like this. If you don't know one of the letters in a vector, you can work it out by working out the dot product, which might have a letter in there, and saying, the question told me it was perpendicular, so I'm going to set that equal to 0 and solve it. We'll see an example of that later on at the end of this video. So, apart from using components to find the dot product, and apart from just writing down that the dot product is 0, if you know that they're perpendicular, the next option is a formula in the formula sheet, and that is a dot b, the dot product, can also be found by timesing together the magnitude of the two vectors times by the cosine of the angle between them. So for example, if I have two vectors and I know that the magnitude of A is 4, and I know that the magnitude of B is 5, and I know that the angle between them is, let's say, 60 degrees, then I can just put all those values in here and get my answer. Now, if I didn't know these magnitudes, remember I do have a magnitude formula that I can use. So if the magnitude of A is 4, the magnitude of B is 5, and I'm going to find the cosine of 60 degrees, okay, which I should know from my exact values is 1/2. So this becomes 4 times by 5 times by 1/2, okay? 20 times by 1/2, the answer would be 10, okay? And that's another way of finding the dot product. But what I would say is that your first two options that you would like to try and look for are they perpendicular, in which case it's 0, or do I know my components? That tends to be a bit easier than doing this. However, this has another use. So let's say instead that I've got 3 points and you're asked to find the angle made by connecting the 3 points together like this. Okay, so let's have a sketch of what that looks like. And whenever I'm asked to find the angle between vectors, I always make a sketch, okay? So ABC. Now it's asking to find the angle ABC. In other words, remember the middle letter is where your angle is. And let's put A, B, C. Now the most important thing to note here is to find the angle between them, I need two vectors that come out from the angle. So I need the vector BC and I need the vector BA, both coming out from B. So what I would then do is then I would work out vector BA, okay, which is A take away B. Now I'm going to pretend that we've got some points up here, and I've gone ahead and I've done A take away B, and I'm going to get the point 4, -1, 5, let's say. And let's say I do the same with BC. So what I would do is I would take these coordinates, I would do C take away B. I'm going to pretend that I've gone ahead and done that, and I've got 0, 3, -1. Now, one reason I wanted to do that question, making it up, is quite often you get maybe a quite tricky 2-mark question in which you've got to find some vectors, and then you've got a big 5-mark question, find the angle between them, or find the angle ABC, and it's worth 5 marks. Now, if you can't find those earlier 2 vectors, you're as well to make a couple up. It's not very mathematical, but it will do really well for working through these papers and picking up as many marks as you can. So the formula I showed you a second ago said A dot B is equal to magnitude of A, magnitude of B, cos theta. Now, if we take those 2 magnitudes and put them on the other side underneath, we get this formula. Cos theta equals A dot B divided by the magnitude of A, the magnitude of B. Now that's great, that's set up for finding the angle between 2 vectors. However, I've got vectors A and B here, they were just taken from a formula sheet. I want to rewrite this in terms of my vectors, and it's very important this is done. So what are my 2 vectors? My 2 vectors are BA and BC. So I'm going to put BA dot BC, and underneath I've got magnitude of BA, magnitude of BC. Now before I can do anything else, I need to know what the dot product is, and I need to know what both of these magnitudes are. So I'm going to go to the side of my page and I'm going to work these out. So let's start with the dot product. BA dot BC. So I've got 4 -1, 5 dot 0, 3, -1. Well, this is going to be 4 times nothing is 0, sorry. -1 times 3 is -3, and 5 times -1 is -5. It's leaving me a dot product of -8. Now let's do these magnitudes. The magnitude of BA. To find that, I'm going to do the square root of 4 squared plus -1 squared plus 5 squared. So that's going to give me 16, plus 1 is 17, plus 25 is going to give me 42. I'm just going to leave that like that, and I'm going to put that in here. It is going to be a calculated task here. And now I need the magnitude of BC. So I'm going to do the square root of 0 squared plus 3 squared plus -1 squared. So nothing plus 9 plus 1 is 10. And again, I'm just going to put that in here. So, as a decimal, -8 divided by root 42 root 10. So I get -0.39. And now what I'm going to do is I know that cos theta is -0.39. So get a bit untidy here, I'm afraid. Theta is the inverse cosine of -0.39. And again, this is one of the other topics where you're not going to need to do a cast diagram. What I would say is you should be thinking of a cast diagram apart from those occasions when you are told and you don't need to. Okay, and your teacher will tell you when that is. So inverse cosine minus 0.39. I get the answer of 112.95 degrees, or 113.0 degrees, depending on how you want to round. So there we go. That's quite a long process. You take your formula, rearrange it, put in the actual vectors that you're talking about. Make sure you make a sketch there to show that you've got two vectors coming out of B, okay, the centre angle. And I would go to the side of my page, find these three things out, dot product, magnitude, magnitude, put them all in, process it, and there we go, 5 marks. And I think a really good 5 marks to focus on picking up. So, the last part of dot product is the things that look kind of like multiplying out brackets. So, I've had this wee sketch set over here. We're now going to find P dot brackets P plus Q plus R. Now, whenever I see this question like this, the first thing I would like you to do is to get these multiplied out. Just like if you're multiplying out the brackets, with the exception that you're going to have dots in between each part. So in other words, P times P, we're not quite going to think P squared yet. We're just going to start by saying P dot P plus P dot Q plus P dot R. Now, it's worth mentioning at this stage that technically I should be underlining everything here. Sometimes I'm going to skip that out, just bad habit, but sometimes just to save a bit of time. So P dot P, okay, I'm going to go over here and I'm going to try and figure this out, okay? So if I use my formula, P dot P equals a magnitude of P cos theta. Well, hang on a second, what is the angle between P and P? Well, if this is P and this is also P, the angle between them is clearly 0. Cosine of 0 is 1. So what this actually becomes is the magnitude of P squared. Now, whenever you see P dot P or A dot A or C dot C, anything like that, you can either go through this process and you'll end up with magnitude of P squared or the magnitude of C squared, or you can just remember that link and write it in straight away. Now, what is P dot Q? Well, there's P and there's Q. They are clearly not perpendicular, so my only option is to go for my full formula. Now, let's work this out here, okay? Do we know what the magnitude of P is? Yeah, I've wrote it down, it's 3. Do I know what the magnitude of Q is? Yeah, I've written down here, it's 2. Times by the cosine of, now I'm going to have to give you the angle between here, so I'm going to say that that is 60 degrees. Okay, cosine of 60 degrees is a half. 3 times 2 times a half will give us 3. Okay, at this stage I probably actually could have put in magnitude of P squared. Well, if P is 3, magnitude of P is 3, then magnitude of P squared is going to be 9. Plus P dot R. Well, whenever I do this, if you noted, I didn't go straight to this formula. First thing I asked myself was, are P and Q perpendicular? And I said, no, they weren't, so I had to do this. However, if I look at P and R, they are perpendicular. Okay, my sketch maybe isn't saying it, but okay, there would have been some greater detail telling you that. Okay, so P and R are perpendicular, so what is the dot product P dot R? Well, it's going to be 0. So put all those things together and we get the answer of 12. So when you see this, multiply out and look at each bit separately, step by step, and see what you can work out. Okay, the shortest one you notice was the perpendicular one, so that's what we should be thinking about first. Okay, are they perpendicular? Okay, dot product with itself, well, we've got that quick step there. And finally, if neither of those things are happening, then we just have to go to a formula from a formula sheet. Okay, so that was A dot B is magnitude of B, A magnitude of B cos theta rearranged. Section formula. So section formula is for when you've got a line or you've got a couple of points A and B and you want to find a point between those and you're told the ratio in which it divides it. So let's say we're looking for the point T, which divides the line AB in the ratio 3:2. So there are loads of different ways of doing this. I'm going to show you the quickest way I think to do it. Now I'm not going to go through why this works. If you ask me or ask your teacher and they will explain that, I'm just going to show you exactly what to do step by step. So to find the point T, now first thing to note is 3:2, it's almost kind of like I'm dividing it into 5 bits here, okay, 3 bits here and 2 bits here, 5 bits, 3 plus 2 is 5. So what I'm going to do is, I'm going to leave a space here, okay, and I'm going to put this 3 with the B. And I'm going to put the 2 with A. So notice that I crossed over there. And one way I like to think of this is that T is being pushed 3 bits towards B and only being pushed 2 bits back towards A. Another way of thinking about it is which coordinate is T closer to? It's closer to B. So it makes sense that B has a bigger number, the more important number in front of it. Okay, so cross those numbers over, put a bracket around it, and we're going to divide that by 5. 2 plus 3 is 5. Okay, what this actually is a shortened version of saying T is 3/5 towards B and 2/5 back towards A. But what I don't like to do is I don't like to divide by 5 in the middle. I would rather divide by 5 at the end. So I've just grabbed this 5 and I've put that at the front. So now what I'm going to do is I'm going to leave this 5th for now. And I'm going to work out, I'm going to write A and B as vectors. I'm going to get numbers and then divide by 5 at the end. So 3 lots of this. Plus 2 lots of this. So that gives me 27, 9 and minus 33 plus 8 minus 4 minus 2. That gives me 1/5 of 35, 5 and minus 35. And that gives me, now I'm going to divide by 5, 7, 1 and minus 7. Now, that's out of a 3-mark question, you've done 2 marks there, and you wouldn't get the final answer because you're missing the most important thing, which was you were asked to find the coordinates of T, okay? And I don't want it written as a vector. So what we need to do is then say, the point T, let's just put this back as a coordinate. 7, 1, minus 7. Okay, there are more ways of doing this, so if you do it a different way, check your notes, see what you've done, but that is my suggested method. The most important thing there is to remember to cross, the 3 comes and joins a B, the 2 comes and joins the A, and also to remember to divide by 5, which is just 3 and 2 put together. So I'm going to finish off with a couple of examples. The first one is from 2014, paper 1, question 14. So I've got vectors u and v, and I'm told that they are perpendicular. So what we're looking to find is the missing value k here. Now what do I know? Well, I know that if they're perpendicular, the dot product is going to be 0. That's what should be jumping out at you from perpendicular here. So I'm say that. Now that tends to be worth a mark quite often for showing that you know the most important piece of information, which is that when vectors are perpendicular, u dot v is equal to 0. So now let's see what we can do with this. Well, let's find out what the dot product is. Now, I'm not going to get a number because of these k's involved, but I can get an expression. So 1 times minus 6 is minus 6, 2 times k is 2k, and 5 times k is 5k. And that gives me an expression for the dot product of 7k minus 6. Now, what do I know about this? Well, I know that that is equal to 0 because we're perpendicular, and from that, I can solve this. So k must be 6 over 7. The next example I'm going to do is also from 2014. This time it's from paper 2, and we're going to do question 4. So what have I got? Well, I've got this picture of some stacked cubes or bricks, and so what have I got? Well, I've got a picture of some stacked cuboids, and first thing I'm asked to do is find the coordinates of C and D. So let's start with that. Well, this is just going to be a visual task. So C, and what I'm thinking is X, Y and Z. I'm going to start off one coordinate at a time and say how far to the left or right. In other words, what's the X coordinate? So C is all the way along, so C has an X coordinate the same as B, which is also all the way along, so it's got an X coordinate of 11. Okay, D has got an X coordinate all the way to the left, as far as these cuboids go, the same as A, so it's got a coordinate of 8. Now I'm going to focus on Y, which is how far back they go. Well, it seems from looking at A and B that one brick goes 4 steps back. So C is 3 bricks back, so it is 4, 4 and 4. It is 12 steps back in the Y direction. D is 2 steps back, so that's 1 brick of 4 and another brick of 4. It's 8 as a Y coordinate. And finally, how tall is it? Well, it seems from looking at B that each brick is 2 units tall. So D is 2 and 2. D is going to be 4 units tall, and C is going to be another 2 units, going to be 6 units tall. There we go. Now, here's where I want to talk about exam technique, because let's say we struggle to find C and D. Well, then we're going to have a big problem here when we're asked to find vector CB. So CB is going to be B take away C, which is going to be 11, 4, 2, take away. Now, if I didn't know what C was, make up an answer. Okay, it's not very mathematical in terms of real life maths, but it will work in terms of picking up marks. Okay, state a made up answer for C and use it, because then at least you're showing what you can do here, and you'll be able to pick up maybe even another 7 marks in this question that you wouldn't be able to do unless you had an answer for C. So as it is, I do know what C is, 11, 12 and 6. So that gives us an answer of 0, minus 8, minus 4. Let's do the same for CD. Again, if you didn't know what D is, make that up as well. Okay, you wouldn't pick up these marks, but you would pick up loads of marks here. D, take away C. 8, 8, 4, take away 11, 12, 6. Gives us minus 3, minus 4, minus 2. So now we're going to find the size of the angle. That's part B done. We're now going to find the size of the angle BCD. Now, if you remember what I said to do whenever we do this, it is make a quick sketch of what angle BCD looks like. So I'll just draw an angle. I always draw it like that. C is the middle letter, and it's going BCD. So this is the angle I'm trying to find. And the reason I draw that sketch is I need to know what vectors I want. So I want the vector CB and CD coming away from the angle. Okay? And as it happens, well, there we go. Those were the vectors that I have already got. So what am I going to need? From my formula sheet, I'm going to need to rearrange that A dot B formula to cos theta equals A dot B over the magnitudes. Now, if you remember what I said again, you will now be rewriting this in terms of the vectors that we have got. So instead of A and B, we've got vectors CB and CD. And now what we're going to do is we're going to separately work out all of this stuff. So we're thinking dot product using components, okay, -1 times 0, sorry, -3 times 0, -8 times 4, and we're thinking magnitudes.
So I'm going to put these back in here and we'll see what we get.
So I know what cos theta is. So theta is going to be the inverse cosine of 0.768. Pop it in my calculator. And I get an answer of 39.8 degrees. Lots and lots of marks in there, but are only made possible because I knew what these were. So make them up if you're not sure. Now, finally, lots and lots more examples in the past paper and vectors pack, so try some of those. If you've spotted any mistakes, I went through this fairly quickly, please just tell me in the comments section and I will double check it.